All right, what's going on, everyone? So this video is going to be something a little different. I'm going to try to prove to you that the number 1 is equal to the number 2. Okay? Now, obviously, you already know that those two numbers are not equal. Okay, but I'm going to try to show you using sound logic, reasoning, properties of algebra that we've already learned, right? That 1 is equal to 2. All right, so I'm going to try to present this as a two-column proof so that you can just see another example of how a two-column proof looks. All right, so I'm going to just go ahead and begin by forming the two columns. Okay, so remember, we're going to be writing the mathematical statements on the left. Okay, and then our reasoning is going to go on the right. All right, so the proof is going to start off with a statement that I'm just going to provide. It's going to be the given statement, right? And that's going to be that A is equal to B, right? So we're just going to assume that there's these two quantities, right, called A and B, and that they're equal. All right, the next thing that I'm going to do is I'm going to multiply both sides by A. So I'll kind of show it and then I'll erase it. Okay. So I'm going to multiply both the left and the right side by A. And so the result is going to be A squared equals A times B. So I kind of erased my work, but you saw what I did, right? I multiplied both sides by the same amount. Okay, so I can now rewrite that the reason why this second statement exists is because of the multiplication property. Okay, more specifically, it's the multiplication property of equality, right? But for short, I'm just going to write the multiplication property. All right, the next thing I'm going to do, again, I'll show my work, but then I'll erase it, is I'm going to subtract B squared on both sides. And so the result of that is going to be our third equation, or our third statement now. Okay. A squared minus B squared is equal to AB minus B squared. Okay, so again, I'm going to erase the work I put in red, okay, but you saw what I did. I subtracted the same amount from both sides. Okay. So the reason why this third statement exists is because I used the subtraction property. Or, to be exact, the subtraction property of equality. Okay, so now I think I'm kind of done with like the basic operations, multiplication, subtraction. And I'm going to use a skill that we learned back in Algebra 1, right? I'm going to factor, okay? So I have a, what would you call it? A polynomial, right, on the left, right? A squared minus B squared. Some of you might recognize that as a difference of squares, okay? And so we can factor that as A plus B times A minus B. Okay. Now I want you to be fully convinced about this proof. So I'm on the side, I'm going to show you how that factoring works, right? Factoring is just the opposite of multiplying. So if I have, A plus B times A minus B, and I'm going to use this box method or area model. I'm not sure what your Algebra 1 teacher called it. Okay, I'm going to use this to multiply these two binomials. Okay, so in the first grid, we're going to get a product of A squared. In the top right grid, we're going to get a product of negative AB. In the bottom left box, we're going to get a product of AB. And in the bottom right box, we're going to get a product of negative B squared. Okay. Now you're going to see that we have two like terms, right? We can combine these like terms, but because they're opposites, they add up to 0. And so the result of all this is just A squared minus B squared. Sorry, you can't see that. There we go. Okay, so A squared minus B squared is the same as A minus B times A plus B, right? So that was kind of factoring that we did back in Algebra 1. Okay, so That's not really the important part, but I just wanted you to be fully convinced of why we're writing, or why I'm writing this fourth statement here. All right, so I factored the difference of squares into these two binomials, a plus b times a minus b. Okay. Now on the right-hand side, I can factor out a GCF, right, a greatest common factor. Okay, so both the first term and the last term have a common factor of b. So I'm going to factor that b out of the terms. So we'll have b there, and then we're going to have a minus b, right, are the factors that are left over. All right, now what am I going to write for the reasoning? I'm just going to write a description of what I did. I factored. Okay. All right, so now we're getting into the interesting part of the proof. Okay, so next, it seems like, okay, so what am I trying to prove? That 1 is equal to 2. And I started with a very simple statement, a equals b, and I've just made it more complex, right? So how is making it more complex going to help me show that 1 is equal to 2? Okay, well, now's the part where we're going to start trying to simplify our statements. Okay, notice that on the current statement, equation number 4, we have a factor of a minus b on both sides. So we can divide both sides by a minus b. And essentially what that's going to do is just cancel all that stuff out. And so we're going to have on the left-hand side, a plus b. And on the right-hand side, we'll still have that factor. Okay, so that's what I'm going to do. I'm going to erase my work and just show the result. Okay. All right, so remember what I said I'm going to do. I'm going to divide both sides by a minus b. So those are basically going to cancel out. And we're going to have a plus b, and then just that b. Okay, now we got to write a reason. And the reason is just a description of what we did. We divided both sides by the same amount. Okay, so we're going to write the division property, okay, as our reason. All right, so now what I want to do is I want to use one of my previous statements. Okay, at the very beginning, we said that a is equal to b, right? So these two quantities, or these two variables, are equivalent to each other, right? So I can replace one for the other anytime I want. Okay, specifically, I'm going to replace the a in my current equation with a b, and I can do that because I've assumed, or I was given, the fact that they're equal. Okay, so we're going to substitute one for the other. Okay, so now I'm going to have b plus b is equal to b. Okay, so I'm making use of the substitution property. Okay, I'm substituting one variable for its equivalent. Again, just kind of erase the work to try to keep this nice and neat. Okay. All right. Finally, on the left-hand side, I have b plus b. So when we combine that, we get 2b. Okay, so now we have 2b is equal to b. Okay, so I just combine like terms there. I'm going to write that as my reason. Okay. So really the reason column is just a record of the steps that we're taking, right? We're just writing a written record, a verbal record of what we're doing. All right, so we're almost there. The last thing that we're going to do is we're going to divide both sides of this equation by b, right? And so 2b divided by b is just going to be 2, and b divided by b is just going to be 1. Okay, so I'll just erase the work, but I will record what I did. I divided both sides by the same amount. So we use the division property once again. Okay, and now I've reached the statement that I was trying to prove the whole time, right? I wanted to prove to you that 2 was equal to 1, right? And I just did. All right, so hopefully you found that somewhat interesting. Okay, hopefully you were paying attention and maybe you noticed that there was a flaw in this argument. Okay, so I did try to be as logical as possible, but there is a point in this proof that is flawed. Okay, and when I see you guys again on Tuesday, I guess it is, I'd like to hear from you if you found the flaw in this proof. All right, thanks for watching, and it's probably close to the end of the period, so I hope you guys have a good weekend.